So what we'd like to do next is be able to separate out just these top faces here and have these essentially get whatever our geometry is that's going to be attached to them, but we want it to adapt to each of these primitives here. So we need to go to our poly extrude and make sure that we are actually grouping these so that we can grab them. So I'm just going to call this extrude front. We can call this greeble me or something like that. Maybe we'll change that later, but start there. And let's just isolate those faces. So I'm going to bring a delete down here, just put it right there. We're already set for primitives. We'll call that greeble me and choose delete non-selected. So let's take a look at just one prim here now. So I'm going to delete. We'll look at just primitive 0. We'll set everything up this way. So again, delete non-selected, and you're all the way over here. Okay, great. We'll put down a test piece of geometry, so we'll just put down a torus, pressing tab, typing torus. Let's take a quick look. Where are you? There you are. Turn off our points for a second. And I want the torus to be on the XY axis. Okay, so we're going to ignore the Z component for now. We'll just stick with XY. And let's talk about how primitives work and primitive space, primitive UV space. So taking a quick look at our primitive here, maybe we'll find something that's a little closer to the center of our world. Okay, that'll work for us. Primitive 104 is great. Okay, so in the world of primitives, we can essentially think about this as a normalized space. So if we assume, and I don't actually know which one of these points it's going to be, but it's really not important for what we're doing. The concept is important and the math will kind of work itself out. But if we assume that this point exists at the coordinate space of 0, 0, 0, so at the axis here, the primitives are normalized, so it takes the it's basically called UVWs, so UV and then W would be a depth component to it. So the U component essentially goes from 0 to 1 as we get to this edge of the quad, and then the V component gets to 1 as we go over to this edge. So it's able to actually have a normalized space. So 0 to 1, 0 to 1. If we can take our object here and we essentially remap this value into the 0 to 1 range, we can remap it on to our primitive just by essentially deciding or figuring out where those world coordinate spaces exist in relationship to the primitive's intrinsic UVs. So prepping our torus, what we need to do first is make sure that our torus is in positive space, and then we need to normalize it so that we're bringing this into the realm of 0 to 1. So let's just go ahead and start doing that with our torus. I'm going to press tab and put down an attribute VOP. And we can call this one make geo positive. We'll simply dive inside here. Now what I want to do is find a quick way of just getting the bounding box of our primitive, and we have a SOP for that, which is called a bounding box, or a VOP for that. So if I press tab and type BOU, we have a bounding box. So we'll just grab that. And for the file, essentially it wants to know which input, and you can see that we have these kind of orangey, dull orange colored here ones. We just want to grab our first op input. So these 1, 2, 3, 4, those correspond to 1, 2, 3, and 4 coming in here. So we're just going to take that and put that right into our file. And we want to take our current position and we want to add the minimum value, the negative of that minimum value. So we know that there's a minimum value here, right? We want to find out what that is and then essentially negate that value and add it into the current position. So we're just going to negate, pressing tab, typing negate, the minimum value. So again, minimum of our bounding box would be from here down to here. That's our minimum. And then let's just add that into our current position. So our current position, right into there, and then set our new position. Now we've moved completely into positive space. You can see as well on the z-axis. Now we need to normalize this. So I'm going to put down another attribute, VOP. Just wire that straight in here. And we'll call this Normalize Geo. Go right inside. And now we'll find out the new bounding box. So I'm just going to press tab and type bounding box. Again, we want our first input. And we know the maximum values here are essentially going to tell us how long or wide or deep the object is. What I want to know is what is the maximum component, because that's what needs to be essentially made to be in the range of 0 to 1, and then everything else will just scale proportionately to that. So if we had some oblong object here, right, that extended out to here, but it was only this high, we want to know what the x component is so that we can make that value 1. So all we need to do is find out what the maximum component is, and there's a VOP for that, which is max vector component. So we just grab that, put that right here. And then we just need to scale. So to do a scale here, we use a transform matrix. I press tab and start typing transform. We have a thing called a transform matrix. And it's just like what you're used to seeing up on the main object level. We have a translation, rotation, a scale, pivot, etc. So we just need to tell it what our point position coming in is. And then of course we spit out our transformation back into a point coordinate. And then here we need to decide what the scale is. So the scale should be 1 divided by our maximum component. So we're just going to put a divide down. I'm going to grab a constant. Make that 1. Put our max component right in here. And then our divide just goes right into scale. So it'll scale proportionately. Let's go back up here, take a look at our spreadsheet, and just confirm our results. So there we go. We see our x is 1, y goes to 1, and then z doesn't really matter, it goes to 0.33 because it's not the same dimensions as the x and y here. So let's go ahead and save. Saving the node type, and then saving our file.